Hello guys, welcome to Solving Solutions on the Barn channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to calculate the land surface temperature of an area using QGIS. So it's simply the temperature of the Earth's surface, typically measured in degrees Celsius or what Kelvin, right? Good. Now, aside the introductory notes we've written, let's scroll down to the general procedure. So we need three bands of images that we are going to use: the bands 10, the bands 3, and band 5. So we need to convert the digital number to radians, convert it to brightness, calculate NDVI, and the rest of that. So now let's see the procedure in detail. So we are going to load band 4, band 5, and band 10. So we have actually loaded the three bands here. The next thing is for us to apply some formula on those bands that we have loaded. However, we are starting with the band 10. Now we have ML times QCal plus AL, right? Good. Now this ML is the band specific multiplicative rescaling factor, which is actually in the MTL file of the data. So if you open up the MTL file, which is still part of what you would have downloaded with your satellite imageries, and then you scroll down, good, so you can see radians multiplicative band 10, right? Good. Now this particular line represents the value that we need on that formula, and then you can see we have 3.3420 times 10 raised to the power minus 4, so that can be 0.00033420, right? Good, because by the time you convert this to normal number, you should be able to come up with this, right? Good. So we can just decide to cut this out of this, and then we take it back to QGIS, where we now open the raster calculator. When we open the raster calculator, remember that what we need is that band specific multiplicative factor. So we just paste that there. Then the next thing is for us to multiply it by the pixel values for band D, which is actually for band 10 rather, which is actually the band 10 imagery, which is this. So we multiply by this, and then the next thing is for us to add, which is plus, right? Good. The AL is radians additive constant, right? Good. So if we still come back here, we have seen the multiplicative constant. If we come to the radians, that's this. For band 10, we are going to see 0.100, right? So we copy that as well, and then we paste it on our formula. So upon doing that, we can decide to create the output layer. Good. So we have navigated to the folder of choice. The first is brightness temperature. So we call this BT. We click on save, and then we click on OK. This is supposed to be the TOA. The next part is for us to now calculate the BT. So we still come back to the raster calculator. Then from the raster calculator, according to what we have from the note here, we are going to convert the TOA radians to brightness temperature, and then we are going to use this formula. Now we have K2. K2 is a constant that we can also find from the MTL file that has been downloaded. However, we have extracted the value for band 10, right? Good. So we are going to impute this value on the raster calculator. So the formula goes as K2, which is 1321.08, divided by the natural logarithm of we open another bracket, K1, which is 774.89, divided by the TOA that we have calculated earlier, and then we close our bracket, right? Good. So this will help us to calculate the brightness temperature. So we still save to file. So this is not supposed to be BT, so let's just call this BT main, so that we can use this to indicate that it is the actual BT. This was supposed to be TOA. Good. The next is for us to calculate the NDVI, which is a bit more familiar. So if we open the raster calculator, the NDVI is simply, you say band 5 minus band 4, which is this should be band 5 minus band 4, then you close that, divided by, you open another bracket, you have band 5 plus band 4, right? So you close that bracket as well, and then you call this NDVI, then you click on OK. Good. Now, having calculated the NDVI, the next step is, okay, that's this, where the NIR is 5 and then the red is what, 4. The next thing is for us to calculate the proportion of vegetation, which is the NDVI minus the NDVI minimum divided by the NDVI maximum minus the NDVI minimum, all what squared, right? Good. So now let's see how we are going to apply that on the raster calculator. Yeah, so we can decide to just open a bracket at first, and then recall that the values of the minimum and the maximum are the values we can see here, right? Good. This is the maximum, which is 0.121167, and then the minimum is what, minus 0.825285, right? Good. So these are the values that we are going to use on the formula. So as the formula states, the NDVI, which is this, minus the NDVI minimum. Now the NDVI minimum is minus 0.82, so minus will go to minus, and then the both of them will just return plus, right? Good. So that's why we are going to use plus here. So we have plus 0.825285, right? Good. Then we close that, divided by, we open another bracket again, and then we have the NDVI maximum, which is 0.121167, right? Good. Then minus the minimum. So since the minimum is already negative, so it will return plus. So we now have plus 0.825285, right? Good. Then we close that bracket. But remember that the all of this is actually squared, so we need to create a second bracket upon which we are now going to apply what, the square. So we now say all of these raised to power 2, right? Good. So we are going to save that, and then that will be what, the proportion of vegetation. So we have that as PV, right? And then we run. So as the PV is up, the next part of it is for us to now estimate what, the land surface emissivity. So we still come back here, and then the land surface emissivity is actually 0.004 times PV plus what, 0.968, right? Good. So we still come back to the QGIS raster calculator, and then this time around, what we are interested in is what, we put 0.004 multiplied by our PV, which is this, then plus 0.986. So we are going to save that to file, and then that will be what, the emissivity, which is what, E, and then we click on save, and then we run. Good. Now the penultimate part will be for us to calculate the LST, and then that will be in what, in degrees Kelvin, which we are going to convert to degrees Celsius. So we still come back to the formula, and then we can see that the formula is a bit long, but we are going to comprehend it as we proceed. So we come back to the raster calculator, and then first off we have BT. So remember that we have BT mean, that's actually our BT. Then we have BT to be that, then we say it's divided by, then we now open a bracket, 1 plus, we open another bracket again, so we have 1 plus the wavelength of what, band 10, right? Good. So we have 10.895, right? So we just copy that, come back here, okay, the fonts are different, so we have that, then we multiply that by the BT again, then we divide it by this other constant, right? Good, which the value is 1.1438 rather. So we come back to the raster calculator and then we still paste that value and then we close the bracket. Upon closing the bracket, we now multiply by the natural logarithm of the emissivity, right? Good, which is E, right? Then we try to close the bracket to have the multiple brackets closed. So we save that to file as well, and then we call this the LST in Kelvin, right? Good. So we click on save and then we run. Good. Now we are at the final stage of today's tutorial. We have gotten the LST in Kelvin, but before ever we do a few styling, we need to convert this LST in Kelvin to degrees Celsius. So we are going to subtract 24273.15 from the LST values in what Kelvin, so that we now have it in what in Celsius, right? So we come back to the raster calculator and then we have the LST we are now, which is this, minus the value we have just copied, right? Good. And then we save to file. So we have this LST in Celsius and then we click on OK. Good. So these are the different products that we have gotten that brought us to this final product of what land surface temperature in degrees Celsius. At this point, we can decide to modify the symbology, single band pseudo color, making this equal interval, maybe trying to make this about 4 classes, reducing the label precision to maybe 2 or 3. Let's just make this red and then let's make this bluish a bit. Okay, so let's just make do with this color ramp. Now this shows that the reddish area contains what higher LST values compared to the bluish areas which contains what lower LST values. So you can decide to modify the symbology to best describe the result you've gotten. So we believe we have shown you exhaustively, walking you through the process of what trying to determine the land surface temperature of any area, right? Good. From having the bands loaded to the digital number to top of atmosphere radiance to the brightness temperature to NDVI to the proportion of NDVI to the emissivity, then finally what the LST in Kelvin and the LST in what in Celsius. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a fantastic time. Bye.